Imagine finding something in space that looks like a planet, moves like a planet, and orbits a star like a planet, but is so massive that scientists have to stop and ask a very uncomfortable question. What if this thing is not really a planet at all? This is 29 Cygni b, a giant world orbiting a star in the constellation Cygnus. It is not close. Light from this system takes more than a century to reach us. So when Webb looked at it, it was not seeing a nearby neighbor. It was seeing a distant object that has been quietly sitting in the dark, waiting to confuse the rulebook. At first, 29 Cygni b sounds simple. It is a gas giant like Jupiter. It orbits a star. It has an atmosphere. It is listed as an exoplanet, which means a planet outside our solar system. But then comes the problem. This object is about 15 times heavier than Jupiter. That one detail changes everything. Jupiter is already enormous. It is the biggest planet in our solar system. It is so large that all the other planets could fit inside it, and Jupiter would still have room left over. Now imagine a world many times heavier than that, orbiting another star, glowing with leftover heat from its formation. At that point, the word planet starts to feel too small. Because in astronomy, there is a strange middle ground between planets and stars. Objects in that zone are called brown dwarfs. They are sometimes described as failed stars because they are bigger than planets but not powerful enough to shine like true stars. They do not become suns. They do not light up a solar system. They just glow dimly and cool over time. And 29 Cygni b sits right near that confusing border. That is why Webb's observation mattered. This was not just another pretty image from space. Astronomers were looking at an object that might help answer a deeper question. What actually makes something a planet? Most people think the answer is size. Small object, planet. Big object, star. But space does not care about our simple categories. Some things are huge and still behave like planets. Some things are not quite stars, but they are also not easy to call planets. So scientists look at something even more important than size. They look at how the object was born. A normal planet forms from the leftover disk around a young star. Picture a newborn star surrounded by a wide, flat cloud of gas, dust, ice, and rock. Tiny pieces start sticking together. Dust becomes pebbles. Pebbles become bigger chunks. Those chunks crash, merge, and grow. Over time, a planet builds itself from the bottom up. That is how planets like Earth formed. It is also how giants like Jupiter are thought to form, except they become large enough to pull in huge amounts of gas. Stars form differently. A star begins when part of a giant cloud collapses under its own gravity. It does not slowly build from small pieces in the same way. It forms from the top down, when a big cloud fragment shrinks and compresses into something hot and dense. So for 29 Cygni b, the real mystery was not just how big is it. The real mystery was, how did it form? If it formed from a collapsing clump of gas, like a tiny star, then calling it a planet becomes harder. But if it grew inside a disk around its star, by gathering material piece by piece, then it may be a planet after all, just an extreme one. That is where the James Webb Space Telescope comes in. Webb did something very difficult. It directly imaged 29 Cygni b. Most exoplanets are not photographed directly. Usually, scientists find them by watching how they affect their stars. A planet may make a star dim slightly when it passes in front of it, or tug the star with its gravity. But direct imaging is different. That means Webb actually separated the planet's faint light from the overwhelming glare of its star. To do this, Webb used a special method that blocks the star's light, almost like holding your hand up to hide the sun so you can see something faint nearby. Once the star's glare was reduced, the tiny companion beside it could be studied. And what Webb found was strange. In the light from 29 Cygni b, scientists found signs of carbon and oxygen. These are not random details. They are clues. They help reveal what the object is made of and what kind of material it swallowed while it was forming. The evidence suggested that 29 Cygni b is rich in heavier ingredients compared with its host star. In simple words, it seems to contain a lot of the kind of material you would expect if it grew by collecting dusty, rocky, icy pieces from a planet-forming disk. That is important because stars mostly form from gas, but planets gather more of the heavier stuff. They collect the leftovers, the grains, the solids, the messy building material inside the disk. So Webb was not just seeing a giant object, it was reading its history. The atmosphere was like a receipt from the object's birth. It suggested that 29 Cygni b did not simply collapse out of a gas cloud like a failed star. It likely grew the planet way by pulling in material from the disk around its young star. That should sound simple, but it creates a bigger problem. If something this massive can form like a planet, then the upper limit of planets may be higher than many people expected. For years, astronomers have debated where planets end and brown dwarfs begin. Some draw the line by mass. Others say formation matters more. If it formed like a star, call it a brown dwarf. If it formed inside a disk, call it a planet. 29 Cygni b makes that argument harder to ignore. Because by mass, it looks suspicious. It is huge. It sits near the region where people start thinking about brown dwarfs. But by its chemistry and orbit, it looks like it formed in a disk, the way planets do. The orbit gives another clue. The object circles its star at a distance similar to Uranus in our solar system. That is far out, but not absurdly far. Webb's research team also found that its path appears aligned with the spin of the star. That kind of alignment is what you would expect if both the star and planet came from the same flat disk of material. Again, the clues point back to a planet-forming disk. This is what makes 29 Cygni b so fascinating. It is not scary because it is about to hit Earth. It is not dramatic because it has lava oceans or glass rain or a black sky. It is interesting because it attacks a definition. It forces scientists to ask whether planet is a simple label or a story about birth. And that matters more than it sounds, because our galaxy may be full of objects like this. Giant worlds that sit near the border, too massive to feel normal, but not quite stars. Some may have formed like planets. Some may have formed like failed stars. From far away, they might look similar, but their origins could be completely different. Imagine two objects with almost the same size and brightness. One was built slowly from dusty material around a young star. The other formed when gas collapsed under gravity. They may look alike in a telescope, but their stories are not the same. That is why Webb is so powerful. It does not just show us that an object exists. It can study the light coming from that object and find clues hidden inside it. It can tell scientists what gases are present, what chemicals are absorbing light, and what kind of material may have shaped the object long ago. For 29 Cygni b, those clues pointed toward a surprising answer. It may be one of the biggest planets we have ever seen form like a planet. Not a normal planet, not a comfortable planet, not anything like Earth. It is a giant, hot, heavy world, still glowing from the violence of its early life, but the evidence says it may still belong to the planet family, and that changes the way we think about planet formation. Before this, it was easier to imagine planets building up until a certain point, and after that, something else had to take over. But 29 Cygni b suggests nature may be more flexible. Under the right conditions, a disk around a young star might build something huge. A planet so massive it almost crosses the line. A world so extreme that it makes scientists question the word used to describe it. The strange part is that Webb did not find this by watching some wild explosion. It did not need a dramatic event. It found the answer in faint light from a distant world after blocking out the glare of its star. That tiny dot of light carried a story. A story about dust turning into pebbles, pebbles turning into cores, and a growing giant pulling in more and more gas until it became something almost too large for its own category. That is the real mystery of 29 Cygni b. Not whether it exists, but what it means. Because if this thing is a planet, then planets can be more extreme than we thought. And if it is not, then our definition of a planet is still missing something important. Either way, Webb has found an object sitting on the edge of two worlds too planet-like to ignore, too massive to explain easily, and just strange enough to remind us that the universe does not organize itself for our convenience. We make the categories. Space makes the exceptions.